Hey everybody, this is the video for task 6. Um, this video will basically show you how to do what you're going to do on page 16 of the packet. So in task 6, you should have already checked your homework answers to the previous one. You're going to watch this short video, and then you will do packet page 16, which is you'll be able to use what you learned in this video on that. So this is not in your packet anywhere, so you can write this on a separate sheet of paper or in your notebooks. So let's say in 1990 there were 50 goats, and each year the number of goats is increasing by 4%. Whenever you're changing by a percent, or if you were, say, doubling or tripling, multiplying by some number, those two things signify exponential growth. So the first part we're going to do is we're going to write an equation for this situation. So we've got y equals, the 50 is the initial amount, kind of like we saw in the bacteria growth. And then the b value, whenever you have a percent, let's look over here to the right, you always start with 100%. If you are going to increase, you would have a plus. If you are decreasing by the percent, you'd have a minus. So we have 100% plus the 4% we're increasing by, that's 104%. And then to switch a percent to a decimal, you always move it over 2 spots. So we end up with 1.04. So that gives you your b value. We talked about with the bacteria growth, anytime you write an equation, tell what x and y represent. So in this case, y is the goats. And because we have a calendar year, x is the years since 1990. You can't just say years, you got to say the years since 1990. So if we did like x equals 2, that would represent 1992. So some follow-up questions that come with us. What if we said, when will there be 75 goats? Well, the follow-up questions are helpful to look at what x and y were. Y was the goats. This just tells us we're going to put 75 in place of y. So we'll start out, we'll put 75 where y is, and we're going to work to get x by itself. So the first thing we'll do is we'll divide the 50 over. And when you put that in your calculator, you end up getting 1.5. Now we want to solve for x, which is in the exponent. Whenever you're looking to find a variable that's in an exponent, we need to do a log. The key thing to remember with a log is your base is always a base. So the base of our exponent is 1.04. That will be the base of our log. So we're going to have log base 1.04. Then the base should switch what it's with. The 1.04 is just with the x. Now it's going to be with the 1.5. So you have log of 1.04 with the 1.5 inside. And now x is by itself. And we can just punch that in, and we get 10.338. So we want to know when it will happen. Well, this tells us during what calendar year it's happening. 10.33, this is sometime during the 10th year. Well, since we started in 1990, 10 years later would be 2000. So sometime during the year 2000 is when that occurred. And then another follow-up question, what if we said how many goats will there be in 1996? Well, we don't know the goats, and the goats was the y. So we should know the x. Since x is years since 1990, we're going to be working with x equals 6. So we would put 6 in place of the x value. We'd type that equation in the calculator, in a calculator page. I said equation, but just the right side of the equation. We'd get 63.26. We're going to round to the nearest goat, so we have 63 goats. So you will use this same process to do page 16, which is the Townville problem. When you get to part B, I noted this in the assignment on Schoology, but in part B, your initial value should not be the same as the initial value in part A. To get your initial value in part B, you will have to use your equation from part A to find how many people are in 1960. And you can round that to the nearest person, and that is what will go as the initial value in part B.